Hello everyone, welcome back to the map of mathematics. In this video we are going to solve this nice algebra problem, and here we have n cubed minus n squared is equals to 100, and we will solve this problem for the values of n. So the very first thing we are going to do is, here first we will move this 100 in the left hand side, and you get n cubed minus n squared minus 100 is equals to 0. After that we will rewrite this equation as n cubed minus n squared minus, here you have 100, we can write this 100 as, we can write this minus 100 as minus 125 plus 25 is equals to 0. And now you can see that we have two pairs, two cubic pairs and two square pairs. So first I can combine the cubic factors. The first cubic factor is n cubed and the other cubic factor is minus 125, so it is 5 cubed. And we have the square factor is minus n square and plus 25, so we can take common minus on both of the terms and you get n squared minus 25 is equals to 0. And now we can use here the two nice formulas, which one is cubic and the other is square formula. So you know that if we have a cubed minus b cubed, it is equals to a minus b times of a squared plus ab plus b squared. Similarly we have the square formula, which is a squared minus b squared. It is equals to a minus b times of a plus b. Now first I can use here the cubic formula in the first term. So in this term we have a is equals to n and b is equals to 5, so that we can apply the cubic formula here and you get the output in the form of n minus 5 times of n squared plus ab. So here we have 5n and plus b squared, and b is 5 squared, minus, here you have n squared minus 25, and we can write this n squared minus 25 as n squared minus 5 squared, because the square of 5 is equals to 25, so that we can write this 25 as 5 square, and we can use this square formula on this term, and you get n minus 5 times of n plus 5 is equals to 0. And now you can focus on both of the terms, and you see that we have n minus 5 be the common term, so that we get in the form of n minus 5 times of n squared plus 5n plus, here you have 5 squares equals to 25. Here we take common n minus 5 and you get n plus 5, and when we multiply this minus on both of the terms, then you get minus n minus 5 is equals to 0. And now we see that we have some little bit simplifications required in this step, so that we will make some simplification here. So we get n squared and 5n minus n is equals to plus 4n, and 25 minus 5 is equals to plus 20, and whole is equals to 0. So here we have two cases. The first case is we take n minus 5 is equals to 0, and the second case is we take n squared plus 4n plus 20 is equals to 0. And in the first case we get the value of n is 5. So this is the first root of the given question. And now in order to find the other roots or other solution of the given question, we need to solve this quadratic equation. But here you remember one thing is that in this question we can find only integer solutions, or here we can just need the real solutions. So that first I can check this quadratic equation has real roots or not by using the discriminant formula. So that by using discriminant formula, here we have a is equals to 1, b is equals to 4 and c is equals to 20. And the discriminant formula is delta is equals to b squared minus 4 times of ac. And here first I can explain little bit about this discriminant formula. If this discriminant or delta gives the value less than 0, then we say that this quadratic equation has no real roots. Or if this delta is greater than 0, then we say that this quadratic equation has two real roots. And if this delta gives equals to 0, then we say that this quadratic equation has one real root. So that now I can check the behavior of this delta by putting the values of a, b and c in this formula, and you get delta is equals to, here you have b squared minus 4ac. The value of b is 4 squared minus 4 times of a is 1 and c is 20, and you get 4 square is 16 minus 4 times of 20 is 80, and 16 minus 80 gives us minus 64. And here you see that minus 64 is less than 0. So this shows that our delta is less than 0, and here we can write if this delta is less than 0, then this quadratic equation has no real roots. But here we need the real roots, so that this equation has less than 0, so it gives no real roots. So if this equation gives no real roots, then we rejected this case, because here we need only real roots, and the real root of this question is the only n is equals to 5, and n is equal to 5 be the final answer of this question. And thank you so much for watching this video. Please subscribe to my channel for more exciting videos.